So we have the substantia nigra here, these black spots, because it's full of neuromelanin, it's full of dopamine. Then we have the third and fourth cranial nerves, oculomotor and trochlear, Edinger-Westphal, and then fifth cranial nerve is down through here. Then we have the medial geniculate nucleus here, which is the relay station for audition. And then we have the superior colliculus here, which are the relay stations for vision. The lemniscus here, remember the auditory brainstem response? So we're just going to look at this area right here. The para-aqueductal gray is here. Remember serotonin, the raphe is down through here, this red mark here. So as you move up and down, you can see the raphe. But we're going to mainly talk about the substantia nigra. Remember the differences between the substantia nigra in a healthy versus a Parkinson's patient. You can't see this black. This black is gone. It's gone because this is gone. And remember the mesencephalon is all of these subcortical areas are surrounding this, the lateral and third ventricle, the ventricular system. Remember the caudate nucleus actually pushes in on these lateral ventriculars. So there's a lot of power here. There's a lot of special nuclei that formed around this because there's a lot of water. And a thing about developing this cell is it needs a lot of water. A huge part of what's going on here is it's interacting with water, especially melanin. And the T3, remember, it's making organelles, mitochondria. If you ever look at the mitochondria, you can see things like, kind of looks like this. This is the inner mitochondrial membrane. And these are complexes, 1, 2, 3, 4. And then the FO head, complex 5, where ATP is made. Cytochrome C oxidase here, this fourth one, is where we make water, H2O. Remember, electrons are coming in. This is the electron transport chain, and it's pumping electrons through this membrane and hydrogen out. Then this FO head will take the hydrogen, pump it back through, and make ATP. ADP to ATP. It's the amount of phosphorus, adenosine, and the amount of phosphorus there. Because this is oxidative phosphorylation, oxygen. Okay, so this area right here is huge for water. And melanin and water, whenever they're coupled, is probably the most powerful things that can provide energy here, especially here. That's why you want this dark. You want that dark. Remember, because this is the source of what modulates the basal ganglia. And this is a huge part about autism and Parkinson's is the basal ganglia, because these will speak up and kind of conduct. If we want to zoom in here, we have the reticulata and then compacta pars, if you want to get down to the nomenclature of it. Okay? Reticulata is GABA, inhibition. It's stopping. Okay? Pars compacta is the dopamine. We have two major sources of dopamine in the brain here. Pars compacta from the substantia nigra, and then another area in the brainstem, the ventral tegmental area. It's also using a lot of power and dopamine and water. So this is more for conducting the basal ganglia, go, no go. And whenever we have autism and Parkinson's, this is off, undisputed. We have a lot of episodes on the basal ganglia, and Dr. Robert Melello talked about the basal ganglia quite in good detail. We could have went on and on, to be honest. But this is off. If you want to compare a normal substantia nigra versus Parkinson's, it looks like this much contrast. Dark, nothing. Because there's a loss of this. A loss of this will mean a loss of this. And a loss of dopamine, okay, so I'll just say a loss of melanin will mean a loss of dopamine, or vice versa.